There. Today we have the second day of solving quadratics by factoring. So yesterday, I have two problems here from what we did. You can see they're both equal to 0 already. All right, so yesterday we said, oh, okay, this first part here and the second part I set each separately equal to 0, and then I was solving. All right, so my answer is x equals 0 and x equals -4. I just solved those two mini equations. Then for problem B, we did first times last and factored, and then set both of those parentheses equal to 0. So let me just write that real quick here. 2x, if you either are doing your shortcut way or keeping your first, keeping your last, that whole business, your answer is going to be these two sets of parentheses. I'm going to set each one equal to 0 separately. So x minus 3 equals 0. X minus 2 is equal to 0. And then when you solve both of those, let me scroll down here. Okay. You add 3 to both sides. Add 2 to both sides. You add, okay, x is equal to 2. And x is equal to 3. Okay, so quick recap. Now let's try the new stuff. I'm going to do 3 problems with you today. So let's do the first one. X squared plus 2x is equal to 3. Oh, this isn't equal to 0 anymore, like we had yesterday. Not a big deal. I'm going to make it equal to 0. We always want one side equaling that. Okay, so I have x squared plus 2x. Now I just moved this minus 3 over to the left side. You cannot combine 2x and -3. They're not both x's and they're not both plain numbers. Okay, so now once I have this, now I can factor first times last, -3x squared, and 2x on the bottom. Find your factors. Let's see. How about 3x and -1x? So that's something, if you didn't realize that, we write out our factors, that whole thing. All right, so keep your first and last and factor. I really want you guys, though, since this is a 1 in front of my x squared, to start recognizing this shortcut. These are my factors. This is my answer. X plus 3. And then x minus 1 is equal to 0. Okay, if you still need to do the long way, I'm okay with that, but I want you to get past that. I want it to be shorter for you. So then I'm going to set, okay, x plus 3 equals 0. Oopsies, sorry. Equals. And x minus 1 equals 0. Okay, so subtract from both sides. So x equals -3, and then x equals 1. Okay, so those would be my final answers. I'm solving. Those are the two answers. I'll put my and sign. That's not a very good and sign, but make yours better than mine. So the rest of the problems on this front side, same idea. You want everything equal to 0. So I would, or the whole side, so I would just subtract over 18 in this example, and then we factor. Okay, so easy enough. Let's turn over to the back side. Do 2 on the back side for you. All right, let's go to number 8. Okay, so number 8, I have 2x squared is equal to 10x. You're probably thinking, what do I do? Okay, when you have an x squared and an x term, you are still factoring. I'm still going to set this equal to 0. So I have 2x squared and then minus 10x. These cancel, so it's equal to 0. Now, when I factor this, there's only 2 terms. Both of them have an x, though. So I'm doing my GCF method. I want to see what can I take out of both terms. The biggest number I can take out of both is 2. The most x's I can take out of both is just an x. So I have 2x, parentheses. Then this equals 0. Okay, let's divide. 2 divided by 2 is just 1. X squared over x is just x. Negative 10 over 2 is minus 5. Okay, so easy enough with the factoring. Now, this part looks different. We haven't seen this type before. But I'm going to set each mini equation equal to 0. So 2x is equal to 0, and x minus 5 is equal to 0. Okay, so x is equal to 0, and x is equal to 5. So I can plug in either of those numbers into this equation, and both sides will equal each other. If I plug in 0, it'll be 0 equals 0. If I plug in 5, you're going to get 50 equals 50. And that's a true equation. Okay. Then the last one. Remember, the theme of today is we have to have one side equal to 0. So that's what you're doing. You're always looking, okay, how can I move something over so they're all equal to 0? I'm going to do number 10 here. I have 9x and negative 3x squared. Personally, I would rather have a positive number in front of my x squareds. So I'm going to move this guy to the left side. So that cancels. So I have 3x squared plus 9x is equal to 0. Okay, this is like that last problem we just did. I have an x squared term and an x term. So I can't use that trinomial method. I don't have a third term. So I'm going to, again, use the GCF method. So I'm going to divide both of them. Okay, I can take a 3 out of both and an x out of both. So 3x, parentheses, I'm going to divide. X squared over x is just x. 9 divided by 3 is 3, and then those x's cancel. Okay, so now I have two mini equations. So 3x is equal to 0, and then x plus 3 is equal to 0. All right, so then you have x is equal to 0, and x is equal to negative 3. So I can plug in either of these numbers to my equation, and they're going to work. Just a reminder, when I have these quadratics, when I have this x squared term here, my graph, is going to look something like this or like this. It's a U shape. When I have two equations as my answer, it's because the U is crossing the x-axis twice. Okay. All right, so there we have it. Those are solving quadratics day 2. Remember, you always want one side equal to 0. In this case for today, the right side is where we're pretty much always subtracting from. So the right side needs to be equal to 0 before you can factor it. It always has. That's always true. Okay, good luck on your classwork.